kind of got surprised. I've been streaming for a couple of days and I don't remember how to do it. Not that I did. Yeah, I wouldn't call myself an entertainer. Or a streamer for that matter. Okay, I gotta fix a couple of things. Can I do this? Oop. Because I remember there was a segmentation fault on this address. Downstream some buffer. Because that's the type that's expected. No, well, a C pointer. I'm not sure what this type is. Yes, cloud, as always. How can I get this type? How can I pass this type in AC? Zig method. It's a C pointer to an optional near peg pointer. What do you mean common use pass null? Some dated a pointer to a pointer. Why couldn't it just be a pointer? I never remember why. So can I just do pointer cast? No, it's already a pointer, so I don't think so. Let me try this. How do I write to the window? Redraw. Yeah, it expects an image. I'm sure image expects a buffer. Oh, it's only a slice of byte. See, that makes a lot more sense. some data dot pointer. Okay, can you actually do that? This needs to be sound buffer size view 8. Okay. Oh, I actually can be a slice of view 8. The syntax is totally wrong. Yeah, I'm gonna leave it as I16 so that I can write it. Yeah, I think I kind of get it. Maybe. I need. But that's wrong. Yeah, that won't work either. What did Casey call it? Forgot. Secondary memory, something like that. I think a secondary buffer. Let's call it sound for now. And move this up. Connected. Is it global? Yeah, it is. Okay. And size of 16. Maybe. I can just check the error. I want to check redraw again. Pointer cast buffered up memory. Okay. And I want to check sync API. Alright. I always forget. The plus. I don't remember. In URL. There we go. I don't need stream begin right. Stream begin right. Can never remember it. Okay, that's correct. Let me just go back. Pulse audio. Function to write data to server. What does it return? Pass in the address to a pointer and an address of the number of bytes you want to write. On return, the two values will contain a pointer where you can place data and the maximum number of bytes you can write. Smaller, you need to be able to handle both cases. Beyond the return value is invalid. Okay, returns null. Let's get rid of this. Play back. Right. Ready. Greater than 0. Okay, that's a simple write. It's for later, anyways. Expected type main.x11 back buffer. Found usize. Oh, okay, that's wrong. $84. Const cost. I have a feeling this is not gonna work either. Yep. Quite tempted to just use the simple one. I might have to go back. Keep the simple one and run it in a separate thread. Okay, I think that seems to be the way to go. Let me check it. Commit. Sorry, git log. Okay. Let's not go back from this. Let me just check out. Git. Maybe delete it later. I should have pushed it. Okay, I didn't. Okay, the audio didn't work. Okay, because I don't call it. Okay. Actually, I just need the samples back. What else do I need? Should I leave sound there? think I can. Excuse me. Move sync sound API. Shit. Well, it's not shit, it's just me. Let me check out. I think that's it. This can go here. $16. Caps lock on. It's doing weird stuff. Sound buffer size. Nah, it's gonna stay there. This is really simple compared to the async one, and the end result is the same, I guess. Play. Audio handle. Oh yeah, I forgot about this. Pulse. Do I use add a? Not sure. I do that. Okay, I didn't really hear anything. Sound buffer size. Sample rate channels. That's weird. I mean, the only thing I can think of that I changed is this. This doesn't make sense either. It's already a slice. Let me check the X11 API. Redraw. Buffer memory. Global buffer. Oh, this is the declaration. Expected type from maybe blah 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 blah. Okay, that makes sense. It's an X11 back buffer. I should just rename that. Call it back buffer. Why can't I hear the audio? Or why doesn't it play the audio? Defined. Well, that could be it too. Hang on. Oh, come on. No errors either, which is weird. What does this return? No, nothing. That's so weird. What does write expect? Data const point to any opaque. And else audio right. Nothing. That's just weird. The only thing I can think of is the only thing I changed is the sound buffer itself. Which doesn't make sense because I was passing in a slice anyways. Am I setting up the audio correctly? Name server. Okay, I gotta check debugger. I wanna check play audio. I don't need. I don't need that. Do this. Should only be one breakpoint. Okay, tone volume is negative. Why is it negative? It looks mostly empty. That's weird. Negative 268. Let me check. Position. Two times by wave position by period. Assign T volume. Maybe I should put it here. And then debug. Okay, tone volume is 268. Okay, it's just too quiet. That's not quiet. Yeah, gets louder. 2000. Yeah, I think that looks correct. Okay, so I guess it's definitely these guys. What is this? Application name. Oh, that's pretty cool. It's not really empty. Why is this in the sound buffer? Okay, it's not empty. Oh, but this is, now we've gone past, I don't know. So why won't you play the sound? Yeah, I can't hear nothing. Am I missing anything else? Yep, sound buffer size times I16. The only thing I can think of is why did it go to negative before? Pero it's less than or equal to the period. My only suspicion, or one of my suspicions, is when I open the server before, the audio server for the async API, I've got to close it. I guess when the program closes, it should, well, it should. Just an assumption. There's no errors either, just like the worst of it. Okay, I know what to do. Take, can I check out? Get checkout there. Just commit this. Leave that simple. Because I guess it's commented out. Okay, so it's definitely something else. Let's get rid of that. Git switch minus. So my only guess is that there is a server running already. Let me just check. Okay, it works. Just wanted to check if the audio works. Yep. Okay, it's definitely. I'll just restart my computer later. Can't think of what else. Alright, let's move on. Because I think. Yeah, I'll do this. Then from my to-do list. This one's done. I'll just call this out. Makes more sense. Still want to do this. RTTSC assembly. Maybe after one update. There's some change to assembly, so you can do it at the same time. Let's close all of this. Okay, let's go. Oh, that was an hour. Let's go ahead. Otherwise, I'm gonna be doing this the whole day.
Started again, so we have a nice clean one to post to the YouTube archive. Hello everyone, and welcome to the 11th day of Handmade Hero, the series where we code a complete professional quality game from scratch right before your very eyes, and we explain every last little bit of it. So for those of you who want to follow along at home, you will know everything that goes into it and why. Now, we have some exciting news. There's a little bit of a caveat to the news, but we have some exciting news. People have been asking for forums and official forums where they can post things and discuss stuff with other members of the community. It is finally ready. I won't say that it's good yet. My web skills are low. I am not a web programmer, and I also tend to get very frustrated anytime I do anything with the web, and there's a lot of cursing and this sort of thing. And so I can't promise you that this site is going to be great overnight. It'll probably take a while to iron out the kinks, but if you go to handmadehero.org and hit the old F5 key to refresh it, you will notice that the link that used to say email a question where you just had to send it directly to me, now actually has a news and forums button that you can click on. And when you go there, you will go to this little Handmade Hero Central thing, and it's got a little news that shows you like the schedule now. That's up there, so if you want to know what the schedule is going to be for the week, you can get to that. There's an episode guide that was put together by some awesome folks, Jace Bennett, Abner Coimbre, Matthew Van de Vender, Gustavo Chavez. I don't know how to pronounce their names correctly, so I apologize for that. These are people that I only know over the internet. I've never heard them even say their name. That is how nice they are. They've put this together for you, and this is pretty awesome. You should check out the work they've done. It's amazing. You can jump to one of these things that one of the videos from a day, and they've made this stuff where they put notes in here when there's notes for the stream, but they put basically like time-coded information where you can just click on the thing you want to know and it jumps to where it is in the stream. So it's pretty amazing. The episode guide is amazing. They've done some amazing work there, and I cannot thank them enough for that. And then, of course, there's a coding resources section that you've got that we're going to be putting stuff in, like recommendations from people. And like if you want to know how to get things running on Linux, for example, David Gao has put together an awesome guide for that, complete with source code. And then finally, there's code discussion that you can click on, and it is a full...
I did see that one, the handmade penguin, but I decided to do it my way. So I didn't use STL.
Full-on old-school web forum, and I'll be trying to clean up some of this. It's a little messy right now, but hopefully that'll give something, get people being able to use something in the short term while we try to clean things up a bit. So that is all the news. I hope that you...
To be fair though, I can always just go back to STL. It's much easier, everything's set up. So
find that to be usable, and if you don't, please post in the forums and we can discuss maybe changes we can make. I'll do the best I can. Like I said, I'm not a web guy, but I'll do the best I can. Last but not least, we have changed so that the pre-order button now goes to Stripe as well. A lot of people were having trouble with PayPal, I guess. I didn't realize how much better Stripe was than PayPal. It's much better experience too. I tried it out. It's way better. You can still use PayPal if you want to, but that changed as well. So we did a bunch of work on the website. Thank you to everyone who contributed to that. It's been awesome, and that is, you know, hopefully it'll all go well. Please let us know if you have any trouble with it, and we'll do the best we can. So that's it for the preamble to the stream. Welcome back, everyone. I hope you had a good Thanksgiving if you're in the part of the world that celebrates that. If not, I just hope you're having a good, a good beginning of December, let's say. Tonight we have a very interesting topic to talk about, a very important topic to talk about, and that is that up until now, we have basically been doing everything in Windows. We have been essentially getting ourselves into position. If we go into our Handmade directory here, we can see that in our code directory, all we have is a Win32 Handmade. And if you remember, I prefixed it with Win32 because this is Win32 code. One of the things that I like to do, and this is very germane to the topic today, which is starting to get things into cross-platform setup, is basically I like to make it extraordinarily clear where the platform-specific code lives and where the platform-independent code lives. And so I, right from the beginning, when we did this, made sure that I specified that that was a Win32 underscore handmade because I like to underscore each particular thing with the platform that it is made to go on. So if there's no underscore platform identifier at the beginning of it, that means that it's generic code that should compile on everything. And if there is a platform-specific prefix to it, then that means it is only for that platform. And one of the things that this allows you to do very quickly is for anyone who's trying to port it, they immediately know exactly what they have to do. They can just do a, dir Win32 star kind of a thing, and they can see immediately exactly all the files that they're going to have to port for their operating system. And that's a big help to anyone. If you've ever actually ported something to a new platform before, you know that just figuring out what you have to port is a huge step. And if the person can set you up for success there, that's a big deal. But point being, we do not have any platform non-specific code at the moment. We were only working on getting a bootstrap up and running. So the first thing I want to do is just talk a little bit about what is in this Win32 file, what we are going to do with it, where it is going to go, just to kind of give people a little bit of kind of a heads up as to what to expect. Because I've seen a lot of people who've done things with the Win32 platform layer and have been talking about things with the Win32 platform layer, and I want to make sure that people don't have the wrong expectations for the code that is in there right now. So I'm actually going to slap a to-do at the top of this, just so people know exactly what's going on here. My keyboard is a little off center. That is not going to happen. That is not going to stand. All right, there we go. Let's see. This is not a final platform layer. And basically what people need to realize is what we have done with our Win32 platform layer, and this was by design, is basically I just wrote the bare minimum stuff in here that we were going to need in order to get ourselves off of Win32, in order to make sure that we basically don't have to think about Windows much anymore going forwards. So I focused on the simplest possible thing we could do for educational purposes, which was getting a sound buffer up that we could write directly into, a graphics buffer up that we could write directly into, and rudimentary input coming in from a gamepad and a keyboard, because that is mostly what we need. There's one other thing that we'll need, which is file I/O, but I saved that for this week for reasons that you'll see a little later. But what that means is I do not, oh, and one other thing, which was timing, knowing how long things take, and we did that as well. So the thing that I want to impress upon you, though, just before we go any further, is this is not a platform layer that you would ship. And anyone who was, going crazy in the YouTube comments, oh my God, he's doing this, or he doesn't understand that, everyone can just relax a little bit. I would not ship this as a Win32 platform layer either, at all, by any stretch of the imagination, but that is not what it is for. Later on in the series, when we start doing work on getting the game shippable, when we start doing that polishing work that we need to do to get the game shippable, that is when we will be concentrating on the correct way to do everything in a Win32 platform layer for maximum compatibility, maximum performance, things like that. But right now our goals are different. Our goals are understanding and education right now, and so the last thing we want to do is spend a ton of time going, here are the 8,000 things you have to do in order to do thing X on Windows properly, because really that just obscures the real point of this series, which is the educational process. So Win32 platform stuff we will get to later, but that is not the goal right now, and so I want to make sure everyone understands that and doesn't read too much into the platform layer code as it is right now. So I'm gonna write in a big to-do list and just kind of say the stuff that later on we'll probably be doing, just so you have an idea of exactly how much stuff we will actually have to go and tighten down when we finally want to ship this, so that you have no illusions about that. So saved game locations is one example. So that's basically like if we have state that we want to save, and we will, where does that go? We have to interface with Windows to find out where that goes. Getting a handle to our own executable file. That is something we'll have to do through this layer. We need the asset loading path, so we got to know where our assets are going to come from. We basically have to have threading, multi-threading, so how to launch a thread. We don't have anything like that right now. We've only got one thread, so if our game wanted to have more than one thread, it couldn't do that right now, so we're going to need that as well. We are going to need raw input, probably. We would like to do some things with raw input, support multiple keyboards, that sort of thing. Support for multiple keyboards. There we go. My keyboard is not aligned properly. There we go. You got to get that alignment or you can't get the speed. You got to get your hands in just the right place. You know what I'm saying? You know what I'm saying. All right, anyway, we have to do sleep and time begin period in order to make sure that on laptops and other sorts of circumstances we do not melt the processor down by using all available cycles and basically burn through the person's battery. Clip cursor for multi-monitor support, because basically right now if we were to go full screen, and I should put full screen support as well. If we were to go full screen, people could move the cursor outside the window and it would be weird even though we're not getting the mouse and that sort of stuff. Let's see here. We want to be able to do WM set cursor as well, so that we basically control the cursor visibility. There we go. We are going to want to do query cancel autoplay, assuming that that even still works anymore, but something that we probably should do, at least for the old days. WM activate app for when we are not the active application. That's a good thing to do. We are going to need to do blitz speed improvements, possibly using BitBlit. We are going to want hardware acceleration, so OpenGL or Direct3D, or both, potentially. Who knows? We could get totally crazy, depending on how things are going. And finally, we may want to do some stuff with get keyboard layout for French keyboards, WASD, basically international WASD, and that sort of stuff. International WASD support. And that is just a partial list of stuff. So basically, that is something to keep in mind. So hopefully that just gives you an idea of how much stuff we actually have to do when we really want to get things into complete shipping state. And we don't need to worry about most of these things for a long time, but it's just worth noting that you should understand what we are doing here is just a very simple layer designed to get us up and running so we can develop the game. And then later, as we go, we may implement some of these when we need them, if we actually need them to do stuff very specifically beforehand. We need to do that. But we also will do them at the end when we're actually just doing ship testing and we're testing on machines and seeing, okay, this didn't work here, make sure we support this there, that sort of thing. Okay, so now that I've got that out of the way, and you understand what's going on in this Win32 handmade file, the main topic for today, the main topic for Monday, is basically how to architect code properly so that it is as easy to make cross-platform as possible. So basically what we're looking to do here is we're looking to make it so that the majority of the code that we write for this project, as much of the code as possible, will be simple for anyone, including myself, but anyone who wants to get running on another platform optimally. So basically there's two goals there. There's just the getting it running at all on another platform. So we wrote it on Windows, we want to get it running on Linux. We wrote it on Windows, we want to port it to Raspberry Pi or something like that, right? Whatever we want to port it to, there's just the act of getting it working. And we want to make that be as easy as possible. But then we also have to think about the act of making it optimal on those platforms, meaning the amount of work that that person is going to have to do. And optimal is probably the wrong term. No piece of code is ever optimal for real. But basically getting it to the point where it's performant, where it runs at a reasonable frame rate for what one might expect the game to run on that platform. So if the platform should be able to run the game at 60 frames a second, but there's a bunch of stuff with the platform that'll have to happen in order to enable that, in order to make that work, what we need to do is say, how easy are we making it for that person who has to do that port? How easy are we making them, making their lives at that time? And now, in this case, it's going to be us. We're going to be doing a lot of those ports. So it's really saying how easy we're going to make our lives. But in general, when you're working on stuff like this, it is typical that you will not be the person, perhaps, that's doing all the porting work for something that you work on. So really, you're kind of trying to keep another person in mind. In some sense, you're saying,
I want to see how difficult would it be to port to Windows. I need... Could move this out. Yeah. Where do I start? Okay, won't be that easy. I mean, yeah, but a bit of a refactor. Because this doesn't exist in Windows, the expanding thing. Configure, notify. This is really the main call. I mean, so far, no. I'm just trying to get window and window and audio working on Linux. I've got both working, sort of. And yeah, and I'm just following along. I mean, it's not really portable right now, but it's good to think about it.
what will the people who come along here and port this to other platforms, what will they have to do? How easy will it be for them to do their job? How easy will it be for them to maintain that port when you update your version of the source? Is that going to require a whole rewrite for them? What's going to mean, right? So those are all the things that I want to put in your head, things that you want to think about, and we're going to talk about ways of making that easier and harder today so that you can see why certain decisions cause problems and why you shouldn't make those decisions and instead prefer things that are going to be a little easier. Okay. So, the first thing that I'd like to say, or really like to introduce you to if you haven't seen it before, is how people in general used to make code be cross-platform. And I shouldn't say people in general, I should say maybe the most prevalent way in the old days. So the most prevalent way in the old days is you would have a file, and that file would be doing something like our Win32 Handmade would be doing, and there would be something like the code for opening a window. So if you look at the code for opening a window here, you can basically see that we have some stuff that we had to do in order to get that to happen. It was right here. Now, the way that people used to do porting to various platforms before is they used to say, well, okay, when I need to do stuff, I'll start at the beginning here, and I'll say, well, you know,
Yeah, no worries. Thank you for hanging out. Good night. Yeah, you should get some sleep.
I'll use the preprocessor. And now, of course, for those of you that don't know, because we haven't talked about it much, in C and C++, there is a preprocessor, and what that preprocessor does allow you to do, along with the one thing that we have been sort of using it for in the past, pound include and pound define, which we've seen, it allows us to do pound if statements, and the pound if statements can take two forms that are kind of equivalent to some degree, but they can take different forms. Basically, what we're allowed to do is say pound if and then some preprocessor expression. Like, for example, pound if is running on Win32. And basically what it'll do is it'll execute the stuff in here. Stuff in here happens when that thing is 1, or sorry, not 0. And stuff in here happens when it is 0 or undefined, basically. So what this allows you to do is define basically sort of macro variables which control certain parts of the compilation so that you can knock parts out when you're on certain platforms and bring other parts in when you're on certain platforms. And so what a lot of people would do is they would define some kind of variable. Typically it would be something like that, because I believe that was the Visual C standard, was basically underscore Win32 or something like this. But you know, it could be whatever. Maybe we'd have our own, for example, like Handmade Win32, and we probably will do something like that for other reasons in a second. But basically what they'd do is they'd have a define like that, and then inside the code, you would basically bracket the things that did not work and provide alternatives. So WinMain obviously would not work on Linux, but you know what would work on Linux? It would work if you were to do something like this, right? This is the way that you would introduce that function in Linux. So something that you would see a lot of times is basically this kind of porting. Oops, I made that a little bit odd there. Basically what you'd see is something like this, and when you would compile this, if you were running on Win32, it would put in the WinMain that looks like this, and if you were compiling on Linux, let's say it would put it in here, and these could even stack on top of each other. There's an elif, basically, which could do something like this, and then we could do, you know, another one down here for a different platform, Handmade Mac, right? These sorts of things. I don't know, it's probably the same on Mac, honestly. I don't quite remember, but well, actually on Mac you want to be in Cocoa, so it's actually an Objective-C and this sort of stuff. But point being, you would see, you know, maybe Raspberry Pi or whatever and stuff like that. Point being is you would see a bunch of stuff like this, and basically what you would do is in each one of these slots, everywhere in the code, you would go in and slot in the thing that you want to have happen. Okay. So basically, let's say that we had done something like that. We've done something like this, and now we've got something that's going to have the correct introduction for whichever platform you would have. Then what you would do is you would go into your build.batch file, and in here you would basically use what's called a compiler, you know, like a compile time pound define. And the compiler basically allows you to do that. You can specify -d, and then you can put the thing you want to define and what you want to define it to in a syntax that looks like this. -d handmade win32 equals 1 means that now I'm injecting that pound define so that anything in the code that does this kind of an if, it will get back a true, essentially. So it will actually do this line. So if I do this compile, yes, I would like to save that build.bat. If I do this compile, you will see that it works. On the other hand, if I was saying for some reason that we were compiling in some other thing, let's say I said we were compiling in Linux or something, you would notice that we would get an error essentially because it's going to actually use this other definition. So it's just a regular function and there's no H instance and all the rest of this code doesn't work, right? But you can see the basic trick here is this is what you do, and you would continue this process to port the whole function. You'd pound if all the Windows code and put else's around it so that you could inject whatever the correct calls were on Linux. Hopefully that makes pretty intuitive sense to you. It's not very complicated, right? It's a pretty basic thing to want to do. There really isn't a lot going on there that's confusing. So I'm going to go ahead and change it back to our other pound define so we can see that this thing works properly, exactly what we want, because we may want to use that ahead, in the future and so on. So that is how you'd have done it way back in the past. I remember reading through like the GNU Make source code back in 1996 or something, and it's just all over the place, this sort of thing, right? All the code has multiple paths. Now, the reason that I do not recommend writing code this way, and we will use a limited, I'll show you a very specific place where I do think that this comes in handy. So I'm not saying don't ever do it, but I am saying think long and hard about doing this sort of thing. The reason for it is because, first of all, it does cause a problem for exactly what I said at the very beginning of this podcast. I'm sorry, the very beginning of this video cast, I guess. This is not a podcast. I don't think anyone with an iPod could be listening to it. The very beginning of this video cast. What I basically said was, we're trying to make the job very easy for the people who have to port it in the future. And if what they have to do is go through all the code, looking for all of the places where we used Win32 code, and pound ifing around them like that, and we just scatter the code everywhere and just do the pound if, that creates a pretty big problem right there. It's just annoying. You can't see where they are up front. You don't even know where all the code is. It's a learning process just for the person to even figure out what was going on. And it forces them kind of into this mindset of, all right, I got to go look at these other sort of if statements and see what each path was doing and whatever. So that's thing one. Thing two is that the code quickly becomes very difficult for anyone to read without basically the benefit of a editor that collapses them. Because if you imagine in here, we have this sort of nonsense going on all the time, right? And remember, it's not just that, it's everything. It's every platform that this thing will ever be pointed to, right? We've got all this sort of garbage going on, right? Then pretty soon, you're basically starting to require, right, a development environment that can understand these ifs and know which ones you have set and show you only the selective code, because otherwise you're never going to be able to read this code. You're only going to see one line of each function at a time because the whole page is going to be taken up with this kind of stuff. And that's just inconvenient right there, and there's a high probability, like Emacs, if you do a bunch of stuff, does actually do that. It's kind of a pain, so I don't do it. But a lot of editors don't do it at all. There's a number of reasons why you don't want to foist that on someone. You're basically putting a hard requirement on their editor, and I'd rather not do that for such a small thing. But those two things, the first and the second one, are small compared to the third one. The third one, I saved the best for last. You know I would do it, and I did. The real reason that you never write code like this unless you absolutely have to is because it dictates the control flow must be equivalent across all platforms. Okay, I'm going to say that again just so you know what I mean, and then I'm going to give an example. If you do cross-platform code this way, it means that the control flow of your program is shared across all the platforms that you will ever ship on. Now, what do I mean by that? Well, what I mean is, if I'm going to go through here and henpeck out lines of code, like I was doing, then essentially what we have is the same set of functions and the same set of if statements, the same set of while loops, and we have just started inserting, very insidiously, different escape mechanisms, escape hatches, if you will, for each platform to go and actually do the thing that they wanted to do at the time that they needed to do it, right? That is very, very problematic when you start talking about platforms that are very different in the way that they expect initialization and platform services to work. So for example, let's say on one platform, in order to load resources asynchronously, so I want to basically have background streaming in my game, I want to load bitmaps out of my resource file, and I want to do that while the game is running. I don't want to stop the game. I want it to happen continuously so there's no loading screen. On one platform, maybe that's best accomplished with a separate thread. On another platform, maybe that's best accomplished with overlapped I/O. Who knows? Maybe it's best accomplished with memory mapped files on one platform. Each one of these things may dictate a very different structure for how the game starts up, how it continues running, how it handles things like messages that come in from the operating system, all those sorts of things. And so what I would like to impress upon you, and this comes from many, many years of shipping cross-platform code, I guess at this point it's 20 years of shipping code that always had to run everywhere, is that it's just a very inefficient way to try and do the coding. The much, much better way is the way that I'm going to show you now. So I would highly recommend not doing this method of coding. I'm going to show you two more methods for.
I guess for Zig, that's not a problem. Because I could just separate out, yeah, the X11 stuff and the pulseaudio stuff. Because the rest of it is going to be the same. Maybe not. Yeah, okay. No, it won't be. Because, for instance, this. Maybe it could be. Run in a different thread. No, what's wrong? Okay, yeah, maybe. Yeah, it's got a point.
For the rest of the stream here, and I would highly recommend, unless for some reason you really love what I just showed you, you really loved this right here, I would highly recommend not using that method as a method of programming, except in one specific instance that I will show you in a minute. Okay, so what are the better ways to do this? Well, I've already set us up for success with one of the ways. And this is common, I shouldn't say one of the ways. Basically, the way that is common between the two methods that I'm going to talk about next.
You know, I'm gonna continue this tomorrow. It's Sunday, so I'm gonna have a short stream. I mean, no, just because it's Sunday. Got a lot of work to do after. Yeah. And I'm gonna do the lazy thing. I'm just gonna restart my computer later. And I think this should work. I'll test it after the stream. And yeah, we'll continue from here tomorrow. I was thinking, should I switch to STL3? But I think it's unnecessary. Got the window working. Audio working. I'm gonna create a thread for the audio, so I can play it without it blocking the main loop. Okay, yeah. And plus I like it. There's no dependency. It's system libraries. It's pretty nice. And what else? I think there's only one more thing that I want to do. There's a lot of to-dos. Yes, leave that in there. Yeah, I want to do this. I'll update Zig as well today, because they have some updates to how to run assembly. And then, yeah, I guess it's everything. Switched back to sync. Pulseaudio. Alright, I hope you have a good day. I'll see you back here tomorrow. Yeah, we'll continue day 11. That's pretty good. I made 11 days. And I find all of this very interesting, even more than the game itself. So, yeah, it's good stuff. Alright, have a good one. I'll see you back here later.